Please tell us who you are and your involvement in IPv6 and the Internet of Things.
I'm Xavier Vilajosana. I'm a visiting professor at UC Berkeley. I come from Barcelona in Spain. I'm professor there at the Open University of Catalonia. And I came here to Berkeley to work on a project called openwsn.org, where we implement an Internet of Things protocol stack using open standards. And we try to contribute on the development of standardization activities for the IPv6 or for the IoT, in fact. So I'm implementer of 15.4e, I'm implementer of 6LoWPAN, I'm implementer of UDP and CoAP on constrained devices. And I work as well on the ITF, especially on the 6TiSCH working group, to develop or to fill the gap on these missing parts that I explained on my presentation.
Yeah. There are missing gaps, I think, and I like how you said it. So you said the IoT stack. So what does the IoT stack consist of?
So we focus mainly on industrial scenarios, and these scenarios have some differences from home scenarios because reliability is very important. So when industrial partners want to deploy a network, they want that all packets arrive because sometimes this is crucial information. So what was the question? Sorry.
So the question was the Internet of Things. On the Internet of Things, it seems like, specifically if we look at the ITF, they work very strong in compartments. But what seems to be missing is something that integrates everything. It's very much an integration play. And when you said the Internet of Things stack, is that kind of looking at all, bringing together all the different standards?
Yeah, so we focus on 15.4 technologies and especially 15.4e because it provides this reliability. And the missing part is that it's not yet IPv6 enabled. So it can be IPv6 enabled, but there's some missing gaps that vendors today are implementing themselves using their own technologies. And the problem of that is that then when you are a big customer and you want to buy that technology, but then you want to change to another one, you have to change everything.
Right.
So there's a big problem here. So at the ITF, what we want to do is standardize that, define what are these missing gaps and provide standard ways to deal with the configuration of that networks.
Okay, so the missing gaps, and that is taken care of where in the ITF?
It's on the 6TiSCH working group.
So that's the TiSCH, and that's it. And when you say the IPv6 or the IoT stack, you're talking about kind of the whole from layer 1 to layer 7?
So, well, we talk about 15.4 as a physical layer, 15.4e as a MAC layer, which is an amendment of the 15.4. Then the 6-top layer that will be defined on the 6TiSCH working group. And on top of that, we have 6LoWPAN that provides IPv6 to these constrained devices, plus UDP on top, DTLS if we want security, and CoAP.
Okay. And was this the main point of your presentation today?
Yes. So the point of my presentation is to explain a little bit how 15.4e works, because it's a pretty new standard and people don't understand well how it works. And also to explain what we do at 6TiSCH and what is our roadmap.
And let's say that I'm a developer, a company, and we're looking at developing an industrial Internet of Things. We're just approaching an Internet of Things service or application. What's a good place to start?
Well, so the first thing is that you have to understand the needs of the market, and you have to figure out what kind of services and communications you want to provide.
Yeah.
So, and if you want reliability, you have to go for, and low power, you have to go for 15.4e technologies, TSCH technologies. And you have always to put IPv6 on them, because then you make them independent on the radio technology.
Okay. And how far do you think it is before IPv6 becomes, I guess,
It's not so far. It's not so far. I think in a couple of years, now there's some vendors selling IPv6 technologies using these underlying deterministic MAC layers. But they still not interoperate because there's this missing gap. But in a couple of years or in a year and a half, we will see more and more vendors selling that technology.
Now, what's the missing gap that's missing right now? What is it?
The 15.4e MAC layer requires a schedule because it's a TDMA, it's a deterministic MAC layer. And the way this schedule is built and managed is not defined. So vendors implement their own way.
Okay. And for information, which vendors are involved right now doing this type of work?
So there's DAS Networks, which is a linear technology company. There's another company called NIBIS. There's different open source projects. Texas Instruments is also involved. There's our project, openwsn.org, which is open source and provides implementation of this protocol stack. And I know Contiki is starting to work on that. So there's many attraction.
Oh, nice. And so if people wanted to read more about your work, where should they go on the internet?
They can look at openwsn.org and they will find all the information.